everybody, this is Miss Emily, and I'm here to do hands-on science with you today. I'm coming to you live from the Oak Lawn Public Library where I'm working this afternoon, and we're doing some contactless pickup, but I'm taking a break to come talk to you about science. So, today we're going to be making some ice sculptures. I've already started building, as you can see. I don't know how well you can see, but there you go. And I've been experimenting with different ways that we can get ice cubes to stick to each other. So, first of all, let's talk about what makes ice. You know that it's water, right? And when you apply a really cold temperature to water, it turns into ice. And to get a little scientific, what happens is water is made up of tiny particles called molecules. And when they're water, those molecules are moving around really quickly and they're very jiggly and flowing. And as the temperature gets colder and colder and lower, those particles start moving more slowly. And as they move more slowly, they form stronger connections and the water becomes hard. It goes from a liquid to a solid. So that's what happens. That's how ice is made. But this process takes time because, as you can see, I've got some ice here in front of me, and it's not really cold in the library today. It's just a normal summery indoor temperature. Now, another note that's going to be important later is, do you know exactly what temperature water freezes at? You probably heard people say, it's freezing outside. And they generally mean it's cold outside, but actually that can mean something very specific. Freezing is 32 degrees Fahrenheit. That is the temperature at which water becomes ice. And those strong connections form and the particles stop moving around so much and we go from a liquid to a solid. Okay, so time to do a little experimenting. My goal was to build an ice sculpture, and I've made some progress. I've got some ice cubes that are kind of sticking to each other, the beginnings of a pretty cool ice castle, right? So I've been experimenting with the best way to get ice cubes to stick to each other, and I'm going to try 3 things here with you right now. One thing I'm going to try is glue. That makes things stick to each other, right? Another is plain water. What if I add some? And finally, salt. Okay, so let's start with the glue because that is definitely sticky and I use it for a lot of craft projects. So I'm gonna slide my sculptures sections over here and make some room. And I'm gonna take out some ice cubes. I have a giant cooler of ice cubes right here next to me. By the way, this is even more fun if you make your own ice cubes for 2 reasons. 1, because you can put food coloring in them and make them different colors, which is really cool. And 2, because you will be able to make ice that's in a more regular shape than just the bag of ice that I got. And that can be a little easier to stick together. But here we go. I've got 2 pieces of ice. All right, there they are. I'm gonna try to put some glue on them. So, first of all, I should have done this before. Make sure that I can get the glue to come out. Come on. All right, it's moving down lower and lower. Can you see it? It's coming. Here we go. We're getting there. Which leads us to an interesting question. Is glue a liquid or a solid? It flows like a liquid, but very slowly. It does take the shape of its container like a liquid, but it's very close to a polymer, which is in between liquid and solid. Okay, almost there. All right, we're gonna have to take this off to get some of the glue to come out. There it is. Looking very sticky. So that looks like a good amount of glue. More than enough, really, on my ice cube. Can you see that? So let us put these 2 ice cubes together. I'm gonna hold them for 20 seconds. I'm gonna do that with each material and then kind of put them aside and give them a little more time. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Then we're going to put it aside and see, I have glue on my fingers, how well the glue holds the two ice cubes together. So, now we need two more, and we're going to try one of our other materials. Let's see. I'm trying to pick ones that aren't already stuck to each other. All right, two more. These I'm going to use plain water. So I'm going to kind of push them next to each other, pour some water, hold them for 20 seconds, and then put them aside. And we'll see all of ours. We'll test them all at the same time. So, pouring a little water, and then we're going to hold them for 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and put them aside. Okay, two more. This time, all we're going to do is put salt on them. So, here we go. Two more pieces of ice. Ta-da! Gonna put them next to each other and just pour a little salt on them. Come on. There we go. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And roll them over here. So now it's time to see the results of our experiment. The first material that we used to try to stick two ice cubes together was glue. So these are my two glue ice cubes. Let's lift them up and see. They are not stuck together. I think you can still see traces of glue. Oh yeah, there's a good, that white did not work at all. These two ice cubes, not attached to each other. So glue is not effective for sticking ice to each other. Let's see about when we just put water on it. Also, in this case, not effective. We'll come back to this in a minute. Sometimes just adding water can help. Didn't work in this case. I hope our last one has worked. Before I check, I'm also going to say that sometimes you have to repeat, in fact, always in science, you have to be able to repeat or have someone else repeat your experiment and get the same results to be sure that your experiment was successful, because sometimes there are variables you haven't considered, conditions that didn't apply, and if you want to make sure something's always going to be true or consistently going to be true, you have to repeat your experiments more than once. So we'll see if we have to or not. Here are my two that I poured salt on, and they're sticking to each other. Yay! Look at that. So, I wonder if that's what you expected. Maybe just because salt was the weirdest thing that I chose to use. But the salt fused those two together nicely. So, now we know that salt is a good material for making ice cubes stick to each other. But why? Can you think of a time that salt is used that is similar to this situation? Like sometime when it's really cold? Maybe you know that they put salt on the roads when it's cold. Maybe you put salt or something similar on your front steps even to try to melt the ice there in the winter. Maybe you know that salt can even be used in making ice cream. Obviously, there's some special connection between salt and a colder temperature. So, I told you before that at 32 degrees Fahrenheit, water turns into ice. It freezes. It also works the other way. At 32 degrees is when ice starts to melt. What salt does is it lowers the freezing temperature. That means that the temperature has to be even lower for ice to form. And what that means is when the salt hits the ice cube, it actually melts a little bit of water. But then, when you put the two ice cubes together, that lowers the temperature there so that that water freezes. So we're just using the ice cubes themselves to stick them to each other. We just briefly lower the temperature at which the water will freeze so that it melts. It gets just a little bit liquid on the surface. We put the two next to each other, And since both the ice cubes are cold, the effect of the salt wears off quickly and the temperature becomes low enough that even with the salt present, they can freeze again. But this time when they freeze, they're stuck to each other. So, pretty cool concept, right? I'm going to continue to build a little bit with some ice. I encourage you to try this as well. And think about some of the other things that might make it easier or harder to get ice to stick to each other. Now, I already mentioned one, which is if you have like a nice smooth shape or surface of the two ice cubes, that's more surface area for them to stick together. So that can be helpful. My ice cubes are kind of round, which means that they don't have a really wide surface area. They don't touch each other in such a large area, and that makes it a little hard sometimes to stick them together. I've also tried stacking them on top of each other, and that works depending on the shape, but just putting them next to each other and then putting some salt on is what works best for me. Sometimes, if they're staying together nicely, I wait a few seconds and then I actually add another ice cube on top so that I'm applying basically more of a cold temperature. This one isn't like a really nice shape. This one's better. I actually put that on top. Sometimes it'll push the two apart, but sometimes if they're already starting to fuse together, I put another one on top, and again, I'm applying more cold so that that one may be able to fuse to the other two. Keep the temperature in between all three of them nice and cold so they stay together even better. So I found this kind of shape, like a pyramid of two and then one on top, was a pretty good way to build. So I've got a bunch of those, as you can see. There's one. There's another one. That one has another one stuck in the back over here, but it has the 1, 2, 3 pattern. There's another one, 1, 2, third one on top. So my plan, eventually, is to make a bunch of these and then start putting them next to each other to start really building like a wall going up. So I'm going to start lining some of them up. Some of these need some more, need the third one on top, so I'm going to start by adding some salt and putting the third one on top. If you have ice cubes that are a little more square shaped, it's easier to just go straight up, to just do towers, one on top of the other. But with these round ones, I found that it was easier to do these little pyramids. And so, this is probably going to start falling down because now I'm moving fast. But I want to start going another level up. So I'm putting a bunch of salt on there and then trying to put this on top. And I'm moving a little too fast. All right, let's see. Nope, I don't think it's ready for that. All right, there we go. That's just kind of balanced. And it's not balanced anymore. Let's see. So you'll have to experiment with whatever shape of ice cubes you have to see if you can get your structure to go taller and taller and taller. Sometimes it's also helpful to put two next to each other flat like this and then stand them up once you have them fused together. So that's another strategy that I have used to get taller and higher. So let's see. All right, this is fused together on one side but not the other, so I don't know if I can go higher with that. I'm going to try adding a little salt here, kind of moving that over. So I really want to add one on top here, but I'm afraid that if I do that, my tower will crash. So it's just about time for me to wrap up and for you to see how tall of a tower you can make at home. I'd love you to measure or send me a picture of what you have going on. And for now, I just want to review what's happening. So remember, you have the power to change the temperature at which ice freezes. Adding some salt, sugar works too, will lower the temperature needed to turn the water into ice. So for a few moments, some of what was ice will become water. And if you put two ice cubes together with a little bit of that water in between them, they will then freeze again and they'll be stuck to each other. And remember that both water and ice are made up of particles called molecules. When those molecules are warm, they move around really quickly. When they get colder, they slow down. They form strong bonds and they become a solid. So, good luck building your ice towers. Remember that sometimes when you're doing experiments, you need to do them more than once to replicate your results to be sure that you have the correct information. And have fun doing your own hands-on science. I'll see you next time.